So, AJ, I'm going to start with you, really, because we've heard a little bit about your work at Llunar Outpost. Is there anything you would like to add to the conversation you've just heard?
Well, yes, absolutely. I think I really appreciated what Edgar told us about earlier today, that NASA is really looking for these near-term missions, asking, what do we have that's ready now? And so I know the title of this panel is upcoming missions. So as you heard from Soterios, Llunar Outpost has 5 rover missions already contracted and several more in the works. Clive, I think your question was a good setup to say, I think there are many folks here who have mature, landing pad, construction technology, sintering, and binding mechanisms. And so the best way to address NASA and Edgar's point is to combine those with our highly mature mobility and robotics systems so that we can, get to the large-scale construction, infrastructure, and habitation goals that I know NASA and everyone here shares.
And I know that you've got a particular contract with NASA, a $1 contract. Tell us about the $1 contract.
Yeah, that was a really exciting initiative put forth by NASA to have a private contractor collect and transfer resources to NASA. And so at the time that was awarded, we recognized that that was a really symbolic and important policy pathfinder for space resources. And so Llunar Outpost bid $1 to complete that activity, and we're awarded that. And so we have now completed 2 of our 3 milestones towards doing that, the launch portion, and, well, actually before that was the mission readiness review and launch. And so we're looking forward to completing the last part of that activity with our MAP rover aboard IM-3 later this year.
And tell us about this collaboration, because I think, ispace, you do it all. But, you guys are collaborating quite a lot. So how does the collaboration work?
So there's a variety of ways that it happens. Not least if we, as a lander provider, have a customer come to us and they want their payload to be on a mobility platform, then we work with companies like Llunar Outpost to find the customer the best solution. There's also a scenario where that goes all the way back to the NASA proposal for the lander itself, in that NASA, as part of CLIPS, now has something called Mobility as a Service. So when you're responding to the NASA task order, you have to go and procure a rover for hosting the payload if you win the lander contract. So there's a range of ways that we interact together.
We know what's happened in the past when things have been landing with ispace or IM. So how confident can they be that everything will go smoothly?
Well, if I'm here next year. So we are very aware on the lander side of the company that IM-3 needs to go really well. We understand very much what happened with IM-2. It's not fully understand that IM-1 and IM-2 look quite similar in their outcome. From an engineering perspective, IM-2 was a much more successful mission in that with the land, we took all the lessons learned from IM-1. They all worked flawlessly until the last 2 hours. And even there, the fault with the lasers that we had was totally different from IM-1. So we've brought in NASA experts and JPL experts for this specific portion of the mission. We've changed the mission profile. We've added additional redundant sensors just for that portion of the mission. So he should be very relaxed.
He looks very relaxed. It's all going very well, and there's no bad feeling
right
here,
now
clearly.
He's got 67 cents, and I need to get him the other 33.
That's right, yep.
Great. And Abbie, I know we need to learn lessons from the past, but obviously Magpie is relying on ispace to do a great job in this case too.
Yeah, but as Ben was saying, we've got so much that we've learned from our previous missions and so many successes that we have achieved, so much that we've managed to gain heritage of, our operations experience. So it's really just that final piece of the puzzle that we're now missing.
And how is the consortium working? Because you laid out very clearly the countries that are involved. It's a consortium, and everybody has to work together. And how has the collaboration building been?
It's actually been fantastic because these partners that we've chosen are people that we've been working with for years, actually, on a variety of different proposals, on a variety of different projects. And so we're old friends. We've been through different rover developments with them. We've been through their payload development life cycle. We've mapped it alongside our rover development. We've made sure that everything is in sync and that we can have models of their payloads to go onto our rover when we need to do system-level testing, and it's all going to fit together. So we're really working as one team now. We have regular meetings, we visit each other's facilities, and it's a really lovely collaborative environment to be working in.
One big family. This sounds all very, very positive. And I know that they're complementary in the science. There's one fully commercial. You've also got one fully institutional. How does that work?
Yeah, so maybe to make the audience aware, for those that don't know our mission profiles, I've been talking about MAGPIE, which is an ESA institutional science mission, but we also have our mission 3, which is a fully commercial science mission, which is actually intended to launch before MAGPIE. And so that one is a fully commercial science mission, but it has a lot of complementarity in its science, in that it's fundamentally a prospecting mission as well. And it's got an M-Solo instrument on board for Magna Petra, who are looking for helium-3. So along with our friends at Interloon, we're looking at helium-3 mapping, but also mapping any other volatiles underneath the surface, which is very similar to what we're doing with MAGPIE. And both of these missions, whilst science-based initially, are then building that picture that we need for that prospecting piece of the puzzle for ISRU missions in the future. So it's all still leading to future missions that will build on the same science, build on the same prospecting data, and make use of it in ISRU ways.
Now, you did mention already in your talk that MAGPIE is part of SMEX, the Small Emissions for Exploration with ESA. Do you think MAGPIE is too small?
Sorry, say that last part again?
Is it too small, what you're doing with MAGPIE? Do you think it could be bigger?
So when you look at our Tenacious rover, which we launched in 2025, that was about 5 kilos. Our MAGPIE rover is around 30 to 35 kilos, including the payloads, and has a lot more capability in terms of the locomotion system, the power system, the autonomy, the thermal control. So we're really about building up these competencies incrementally, so that we have more chances for success with each mission, rather than jumping straight in with a 1-ton rover that we have to develop all of the systems for simultaneously, and that all has to work first time to have this multi-million-dollar mission work. If we do this incrementally in smaller steps, we have more chance of success, more learning opportunities, and that makes us get, hopefully, to our end point of a 1-ton rover system faster, but also with less risk overall.
I was going to come back to that, but since you've mentioned it, tell us a bit more about your partnership with Toyota. I will then move on to you, Ben, don't worry. Partnership with Toyota.
Yeah, so ispace obviously are currently working on what we could really term as micro rovers, so sub 100 kilo class rovers. But Toyota, and through the JAXA Space Strategic Fund, are looking at these much, much larger crewed vehicles, pressurized vehicles for human presence on the lunar surface. And so Toyota is partnering with ispace to help us to develop our smaller scale rovers, but also so that our rovers can inform their larger scale rovers. Much as I've been saying, taking those incremental learnings, how does the soil, the regolith, impact our motors? How do our batteries fare over time? What's the radiation damage that we're getting on our power systems? All of these things that we can learn from our smaller scale rovers and can scale up, because the same challenges exist for the larger scale rovers. And if we can learn it with a much cheaper, much faster mission and know that information in time to inform their design, then everybody's a winner.
Thank you. Sorry, Ben, I know you've been sitting there very patiently. I'm coming to you now. I want you to tell us a little bit more about the $800 million acquisition of Lanteris. You talked about it. It seems very, very positive. Is it all positive? You're amongst friends. You can tell us the truth, really. And did it change the center of gravity? Did you have to rethink how you would function?
First of all, yes, it's all positive. It does. One of the reasons it's worked is we've jumped from about a 400-person to 1,600-person company, but the ethos of both companies are both very, very similar in positive, in a new space way of working. So I've been fortunate enough to go out to their facility in Palo Alto, and it's an incredibly exciting, as they try to convey additional capability where they can also, we're already looking at ways that we leverage off each other's experience to make what were our original core capabilities better.
Well, that sounds all very, very positive. And then I wanted you to talk more. I mean, we've heard it from everybody, really. We heard it from NASA. We heard it from you as well. The mission cadence, it's increasing dramatically. We're going to have more opportunities for other players. So I guess one thing that everybody here will be interested in, I think, is who can now be part of this who couldn't afford to pay before. So who are you looking to bring up into your systems?
Yeah, so I think, Edgar had that excellent slide earlier where he talked about phase one, and whereas CLIPS right now is, stated to be roughly 2 missions a year, this is a particularly bumper year with 4 CLIPS providers going. But Edgar showed the chart, and Isaacman has talked about potentially up to 10 lander missions a year. I think what's exciting, there's multiple reasons that's good for this community. The first is you're just going to have a lot more mass going down to the surface that's available. So your availability will improve. Also, in order for the companies like us to be able to produce multiple landers, you're going to have to change slightly from, right now, every lander it's slightly bespoke depending on the payload. You can't do that and then increase the cadence of missions as well. You've got supply chain thing. You're going to have to go to much more of a standard, this is the lander of this class. So I think it'll help this community plan as well on how they get their technology demonstration flown. I mean, this is an amazing meeting. I really enjoy it. It's going to be an even better meeting once you've got people up here actually showing their technology demonstrated on the moon.
Thank you. Well, let's hope that happens very soon. I think it will. And AJ, coming to you as well, I want you to tell us a little bit more about the big visions, the vision for Eagle Lunar Terrain Vehicle. That's a massive project, NASA's $4.6 billion.
Yes, of course, and I think that's particularly relevant to this really resource-focused group. I always like to say, if you look at a resource extraction site here on Earth, at a mine site, you see pickup trucks everywhere. But the mining company didn't have to invent the pickup truck. They didn't have to build their own pickup trucks because there were already excellent commercial options available. And that's really what the Lunar Outpost Eagle Lunar Terrain Vehicle is meant to be. It's a commercially available work truck for the moon. So it serves to enable all of those activities that need mobility and robotic capabilities by developing that in advance and having it ready to be fielded, much like Ben said.
Well, since we have such an active and eager audience, I would like to open up the floor again in our last 10 minutes to questions from the audience. Oh, yep, hand right here, and another one there. Yep, thank you very much.
Hi, I'm Sujit Pal from Public Access. I had a quick question. Given the SpaceX IPO coming up, does any of your companies feel threatened by this juggernaut of $1.75 trillion worth of market capitalization walking all over everybody?
Well, thank you for such a good question. The SpaceX IPO.
Threatened? No, I think this is a great sign for our industry. I mean, we talked about how the first Space Resources Week was here in 2018, and I recall that we were talking about, how can we accelerate the pace of what's happening in our industry? And now here we are in 2026, seeing it happen. I think the SpaceX IPO is, just another sign that now is the time to be, doing this work.
I think ispace, right from the very beginning, have been very clear that we want to grow the lunar ecosystem, and we want to create an Earth-lunar single system where both parties can benefit from the technologies available on the moon, the resources available on the moon. So we're really looking to grow this ecosystem. We're encouraging anyone to join the ecosystem, and any kind of growth of that ecosystem can only benefit us as a player within the ecosystem.
Okay, thank you very much. Yeah, we have a question. Oh, great, they're flying around. Brilliant.
Omid for Earth to Mars. Ben, thank you for your explanation about landing pad. But your answer created two questions in mind. I wanted to understand this very well. Do you think the plume surface interaction is not a serious problem, so we can study this later, so this problem don't put your mission in the danger or risk? Or you say that because you don't have a solution for landing pad yet? Thank you.
Sorry, I missed the first bit. Do I think what's the problem?
Do you think the plume surface interaction is not a serious risk, so we can eliminate that at the first? Or you say that because you don't have a solution for landing pad yet? Thank you.
Okay, if you're going to phrase the question like that. So yeah, I think the answer is no, we don't think it's a problem. You can go back to Apollo. Very large landers have been landed on the moon. You don't get massive subsidence. So no, where I think it becomes a problem is, and Clive touched upon this, is when you need multiple landers landing close to each other. I think the problem is not the interaction between the plume and the surface. Certainly at the cargo class landers like we're doing, which could be up to a few metric tons, I think where it becomes a problem, where I think landing pads could become one of the solutions, is, like I said, if you need to land things fairly close together and regularly. And I don't think it's fair to say there isn't a solution. There's been a lot of excellent work done terrestrially with Simulant, looking at that, yes, microwave sintering is one, and that's also good for roads. But there's also people who build 3D blocks, or there's doing berms. There are lots of solutions which have been demonstrated on Earth with Simulant that I think it'll be extremely exciting when we get to the scale of operations on the moon, that we need to demonstrate all of those and see which one works the best.
Thank you. I think there was a question. Oh, it's Clive.
Yes, hello again. Question for Abbie about the ispace Mission 1, Mission 2. There was an independent review board put together by ispace Japan. I assume that they've made their findings because we've got the next Mission 3 coming up. How has that influenced the thinking in ispace? How has it changed things?
Yeah, I think you can see it in our press releases at the moment, so you can probably find better and more accurate information there than I can summarize in just a few seconds. But it's definitely influenced our thinking. We've actually made some fairly substantial changes within the company, within our mission pipeline, and some of the architectural decisions on our lander as well, to avoid risk areas that have been highlighted by this review board.
Yeah, there's a question. I was just going to follow up. I mean, I assume that you follow what happens with them. Did you have any thoughts on what happened with ispace? And
No, I don't think it's... no, it's not right to comment. No.
Not to comment negatively. I just mean to learn or to think,
yes.
what happened, and
Yeah, I think ispace were very open in what happened, and I think that's very positive. It is a compromise between sort of sharing intellectual property versus you get a lot of perception from audiences that there's a massive competition and you want others to fail and you to work, and that isn't true. I think Abbie described it well. Is what we want is 20 years from now there to be a robust operations on the moon which requires multiple providers, because everyone will have a niche which they're particularly good at. And again, it comes back to the SpaceX IPO. If a moon base becomes real like we hope it is, you want multiple providers because that's healthy.
that sounds like a very, very good, healthy competition and healthy amount of IP being opened up and not opened up.
Yes, another question for Ben again.
Sorry, really close. It's so hard to hear here.
I appreciate your point about the unit economics, where you start to standardize and then produce a lot of different landers that improve the cost to the lunar surface. What would naturally seem to follow is that one day you would think about reusability of your Nova C landers. So have you considered switching from methalox to hydrogen-oxygen, which could obviously be refueled with lunar ice potentially one day?
Sustainable landers.
Yeah, so I think where that will come in again is, what you could totally see happening is a lander of that Nova C class becoming a regional transportation capability, whereupon, yes, you'd either have to have, in our case, LOX methane capability, or you have to look at doing another fuel. I think we know there are other fuels out there once we see a demand for reusability. I think it's another example, to come back to the question about SpaceX, you're not always going to want a Starship to deliver, as the old sort of adage goes, you don't get a semi deliver your Amazon small box to your house. And so there will be a need for regional transportation, which can be both rover, hopper, and potentially reusable landers. So yes, we have been looking at that.
Thank you. Any further questions from the audience?
Just hello. Okay. Just to follow up on the SpaceX question, what if the unit economics by SpaceX through its program drops the cost so low for their delivery mechanism that it changes the competitive dynamics for each of your individual delivery systems?
You're asking ispace. Did you say ispace to reduce their costs?
It's for everybody.
Oh, all of you. If you all reduce your costs.
Yeah, no, what I think he's saying is, if spaceship, if I can give your question back to you just to check I've got it right. What I think you're saying is, what happens if Starship flies so regularly that the cost per kilogram to the lunar surface? And I think, weirdly, I answered that question with the previous answer, which is, yes, there will be infrastructure in placement which is perfectly suited for a Starship scale landing. But don't forget, that economy of scale, because you're talking about price per kilogram, is only relevant if you're delivering that full payload or a large amount of it. So it could be that, for example, if you want 3,000 kilograms delivered to a particular location, I would argue that a Starship isn't necessarily the cheapest answer at that scale. It could be a lander that's optimized for 3,000 kilograms.
I would counter that by saying, if the cost is $500 a kilogram, I myself and my friends will send payloads regularly just to run experiments on the moon. It doesn't matter at that point if it's running at point A, point B, or point C, because now it opens up the competitive dynamics of anybody who was not a customer now becoming a customer just because they can afford it. It's like if you can get flights to Casablanca for $10, would you go? Probably, just because it's $10.
Well, you're making your case very strongly. Would anybody like to talk about the infrastructure versus what might happen with the payloads once they get to the moon? Because one part of the economy is the infrastructure. Another part of the economy is what you do on the moon.
Well, I can speak from the perspective of a mobility provider like Lunar Outpost. I mentioned the Eagle lunar terrain vehicle, and one of the key features of that is we have interchangeable payload interfaces in the bed and a robotic arm so that we can deliver smaller unit payloads to different sites, return to a launch vehicle, resupply, and drop off even more. So from that perspective, I think we're on board with everybody sending their payloads sooner.
And if I can add to that, I touched upon in my talk the idea, we're putting in communication infrastructure. And again, what I think is exciting for this audience, and it comes back to, you want to fly things when the price point comes down, is I don't think we're far away from where, to sound slightly harsh, you don't have an excuse for not going. I think we're not far away from you not having to worry on the how am I going to do it. You just need to worry about the doing of it. Whether that's so much mass is going down to the surface that you've got an opportunity at the price point that you want, that you've got communication relays so you know that your data come back anywhere on the moon, so you've got multiple mobility platforms on the surface, so you don't have to worry about a rover. There could easily be 2 or 3 LTV class rovers there that they compete for your business to move your equipment around.
I think a different part of your question is, do you worry about the potential monopolization of a certain part of the industry?
Thank you.
I think that depends what you want to specialize in. If we're talking about bulk transport of a lot of kilos of something to a single spot on the moon, that's not a market that ispace is trying to compete in. What we are trying to do is to tailor missions to support the payloads that are specific to wanting to go to the places that we're going, to maybe provide them with extra functionality that they don't design themselves. Maybe they need a robot arm, or maybe they need a scoop, or maybe they need to be fed with regolith from a certain place. So are they going to get as bespoke a service from SpaceX? Maybe not. So maybe there's still a market for those kind of customers for ispace.
And I would say the good thing about the way that commercial companies are now involved in the lunar infrastructure is, if you do end up with a company that for a period of time has a monopoly on a particular service, if they're not providing a good product, or if they're overcharging for that product, then you will get other companies come in and offer competition. So I don't think an unhealthy monopoly would last very long.
AJ?
Oh, I agree exactly with Abbie and Ben.
I think just one follow-up thought on that then, which is veering the conversation slightly sideways, which is, how much effect does such a company have in designing the ecosystem that we are all talking about?
Are you referring to SpaceX? Well, I would argue that the ecosystem right now is being designed by the space agencies, and the companies will react to that. So I don't think that SpaceX are designing what the lunar moon base is going to look like. They will want to play a role, I'm sure, in its emplacement, as we all will. But I think the fact that we heard today that you have multiple space agencies working together on this means we should get a healthy ecosystem that everyone can play in.
Thank you. Anything else you'd like to say? Any final thoughts or questions from the floor? One more final thought, and then we can wrap up.
Good evening, Lorenzo Di Mattia from Politecnico di Milano.
You have to be super close.
Okay, is it better? Okay. General question, maybe mostly for AJ. Since we have been talking a lot about the moon base, most of your renders have been showing infrastructures brought from Earth, and it's the main topic of the discussion here. But have you been actively investigating the possibility of using regolith directly on the moon to realize outposts and shielding infrastructures? Since China is also being investigating that a lot recently.
Oh, absolutely. I'm a huge fan of in situ resource utilization. In fact, that's what brought me into this space in the first place. So, I love that throughout this week we'll hear from, a very broad, speaker base, very diverse group of technologists and, people looking to do those sorts of things. And so, yeah, we're absolutely looking to partner with them and provide, what we can, the mobility services to complement those ISRU activities.
Thank you.
I think people often, when ISRU is used, people automatically think of extraction and extracting water. And really, ISRU is just making use of what you find. So I think, again, once we get to very quickly, people are going to be innovative and work out where doing things with regolith, which is abundant, is a better solution than bringing something from Earth.
Thank you. Thank you so much to the panelists. Thank you very, very much indeed. And now for those of you, thank you for remaining in the room. I can see that we've lost some to the alcohol outside.
I can see it.
You can see it, we can hear it. We can see it and hear it. So thank you very much. It's the end of day one. Please be back here for a 9 a.m. start tomorrow morning. But do enjoy Luxembourg this evening. And before you go outside to enjoy Luxembourg, we do have cocktails and encourage you to talk to everybody who is standing by their poster. Thank you very much. Thank you.